All right, let's talk about one of the most common snacks on the entire planet, the good old biscuit. But have you ever really stopped to think about what makes one so different from another? I mean, really think about it. That perfect snap you get from a cracker versus the way a shortbread cookie just melts in your mouth. That's not some happy accident. It's all about some pretty amazing chemistry and engineering, and today we are going to pull back the curtain and look at the blueprint behind it all. So, here's our game plan. We're going to start with the basics. What even is a biscuit? Then, we'll dive into the two major families they belong to. From there, we'll follow the whole journey, right from mixing the dough and shaping it, through the crazy science of the oven, and all the way to the package on the shelf.
Okay, so, first things first. What actually makes a biscuit a biscuit? Well, believe it or not, the clue is hidden right there in its name.
The word itself comes from the Latin biscoctus, which literally means cooked twice. See, the original idea was to bake all the moisture out so they'd last forever on long sea voyages. And that same idea holds true today. The #1 goal of any biscuit is to have a super crispy texture and almost no moisture. Everything we're about to look at is designed to get that perfect dry crispness.
Now we're getting to the heart of it. You know, there are thousands of different biscuits out there, but they pretty much all fall into two main families. And the big difference between them? It all starts and ends with the dough.
And this table right here, this explains everything. On one side, you've got hard dough. It's got lots of water but not much fat. That lets these long, stretchy strands of gluten form, kind of like in bread dough. That strong, elastic gluten network is what gives you the layers and the snap in a cracker. But then, on the other side, you have soft dough. It's packed with fat and sugar but not a lot of water. That fat actually coats the flour and it stops the strong gluten network from ever forming. What you're left with is this weak, crumbly dough. It feels like wet sand, and that's what bakes into those tender, crumbly cookies and shortbreads. It is all about controlling the gluten.
So let's head to the factory floor and see how it all begins, the mixing. Now this isn't just about dumping ingredients into a bowl. It's a super controlled process, all about building the perfect foundation for the texture you want.
For the really high-quality hard doughs, they use a 3-stage method. First, the fat and sugar get creamed together. Then, separately, the leavening agents and flavors are activated in water, and only then, at the very end, is the flour added. This careful step-by-step process makes sure every single ingredient is perfectly distributed, which is what you need to build that strong, even gluten structure we were just talking about. There are simpler ways, sure, but this is the gold standard.
And the level of control here is just incredible. We're talking about a precise mixing time, somewhere between 10 and 15 minutes. The dough's temperature has to be kept in a really tight window, between 35 and 42 degrees Celsius. But there's another secret ingredient, the leavening agent. A lot of the time, it's a chemical called ammonium bicarbonate. And here's the cool part. It only starts releasing gas when it gets hot, like over 60 degrees Celsius. That means the dough doesn't rise at all during mixing. All of that lift, all of that puff is saved for when it hits the oven. It's all part of the plan.
Okay, so the dough is mixed. Now it has to be shaped. And how you do that depends completely on which of our two biscuit families you're dealing with.
That strong, stretchy, hard dough, it's perfect for rolling. It gets passed through a whole series of rollers that press it into a thin, even sheet. For things like crackers, those sheets get laminated, which is just a fancy way of saying they're folded over on themselves again and again to create all those delicious, flaky layers. Then a cutter comes down, stamps out the shapes, and embosses any patterns. But you could never, ever do that with a soft dough. It would just crumble into a million pieces. Because it has no gluten strength, you can't roll it. So instead, that crumbly dough gets pushed into something called a rotary molder. It's basically a big cylinder with the biscuit shapes carved into it, and it gently presses the dough into its final form, intricate patterns and all, before dropping it onto the baking belt. All right, time for the main event, the baking. A biscuit goes into the oven as this soft piece of dough, and it comes out the other side as a crispy, finished product. This amazing transformation happens inside a massive industrial oven, sometimes over 40 meters long, and it's a journey through 3 very distinct zones.
So, in Zone 1, you get what's called the oven spring. The heat hits our leavening agent, water turns into steam, and everything expands really fast. This creates that porous, airy structure inside. Then in Zone 2, it's all about color. Moisture is escaping, the crust is forming, and you get that beautiful golden brown color from the Maillard reaction and sugars caramelizing. Finally, Zone 3 is where the magic snap comes from. This is the last drying stage, where the whole structure just sets hard and gets perfectly crisp.
And what is the single most important goal of this whole long journey through the oven? It's getting the final moisture content below 5%. That is the magic number. If it's any higher, you lose that crispness and you seriously shorten the shelf life. This right here is what defines a true biscuit.
But hold on, the journey isn't quite over when the biscuits roll out of the oven. There are still a few really important final steps before they're ready for you to eat. First, they have to cool down, so they travel along these long conveyors until they're at room temperature. Some products, maybe some crackers, might get a quick spray of oil for extra flavor and a nice shine. Others get sent off to have cream added to make sandwich biscuits. Then, after a final safety check through a metal detector, automated machines stack them up and wrap them, ready to be shipped out.
So you see, it all comes back to this one idea. This quote really nails it. The difference between the snap and the crumble isn't really about baking time or the oven temperature. It's all about controlling a single protein: gluten. For a soft dough biscuit, the entire process is basically a fight against letting gluten form.
And there you have it, a snack that seems so simple, but it's built on some incredibly complex and precise science. It kind of makes you wonder, doesn't it? What other foods sitting in your kitchen right now have a secret story just waiting to be told?